Hello, pre-calculus students, seekers of truth. We will continue our study of sinusoids here by looking at some of the features of a sinusoid. Because these graphs are basically waves, we have some special names to describe these features of the waves. And the first one is called the amplitude, which is the distance from the middle of the wave to the top or to the bottom of the wave. And we can actually categorize this or reflect this definition by using a formula. It's the max value minus the min value. And this here, when we say max and min, we're referring to the y values of the graph, the output, right? So let's see why this is the case. So let's say we have a graph here. This is a sine wave, right? It goes up and down, and there really are an infinite number of maximum and an infinite number of minimum points here. But the maximum point here is 1. The minimum point, the lowest that it could get, is -1. So let me be clear. This is the sine graph, right? So if you think about this and what the definition is saying, the distance from the middle of the wave, well, the middle of the wave is right here, to the top, right? So that has a distance of 1, or the distance of the wave to the bottom, from the middle of the wave to the bottom, that also has a distance of 1. Right? And so we can actually calculate this number by using the following formula. The amplitude is 1/2 the max minus the min. So in this case, for the sine function, the amplitude is 1/2 times the maximum value, which is 1, minus the minimum value, which is -1. So this turns out to be 2 times 1/2, so that's just 1. All right, so and this here we're talking about distances. So on this graph, so these distances are positive, but when we're talking about values, the minimum value in this particular case happens to be -1. So max minus min divided by 2 is the amplitude. And you might hear this discussion in some other classes, like science classes in physics, where this might be referred to as the wavelength, which is another common way to describe these graphs. All right, so now let us talk about some other cases where we may not have the original parent function. We have some transformations here. So this 3 here, remember, this is a vertical stretch of 3. Okay, so when we graph f of x, it's going to look something like this graph that I'm drawing here. Right, and notice I'm trying to draw as much of this without a calculator as I can. Instead of my graph having a max and a min of 1 and -1, it's going to be vertically stretched upwards and downwards, so that the max value now will occur at +3 and the minimum value will occur at -3, and the rest of the graph would look roughly the same. Right? So it's still this wave. And it's good for you to have a calculator to confirm this. Whoops, I messed this up though. I'm talking about the sine function. So it should start out here instead and go up and then go down and then up over here. So this is the sine graph, 3 times the sine of x. Well, the maximum here, and let's get really, really specific, the maximum value here is at pi over 2 +3. The minimum value here is at 3 pi over 2 -3, right? And again, when we talk about max and min, we care mostly about the y values here. Okay, so then the amplitude of this graph is 1/2 times the max, which is +3, minus the min, which is -3. So this turns out to just be 3. All right, so that's the answer to the first question of f of x. Now let's look at g of x. So we have here a 4 and a negative. So it is reflected over the x-axis. That's what the negative does, right? And it has a vertical stretch. This has a vertical stretch of 4. So now when I go to graph this function, and keep in mind this is the cosine function. Now the cosine function usually starts out at a maximum point, but because it's been reflected over the x-axis, it's going to start down here. This is going to be at -4, and up here you have +4. So it's going to look something like this. So this is g of x is equal to -4 cosine of x. All right. And you can see here that not much has changed. The minimum is, this is one of the minimum, it's 0, -4. The maximum here is going to occur at pi positive 4. So the amplitude here is going to be 4. I hope you can see that. It's 1/2 the maximum value minus the negative value. So 4 minus -4 is 8, divided by 2 is still 4. Okay, so you can see here, hopefully you see that there's some pattern here, that this 3 in the front causes the amplitude to turn into 3. This -4 here turns into positive, causes the amplitude to be 4. So one of the things that it's important to point out is that the amplitude is always positive. Always positive. Even if the number in front is a negative number, the max is going to be always higher than the min. So when you subtract the two, you're always going to get a positive number. And if you scroll back up here to our definition of a sinusoid, you can see that the variable or the letter a in the front here is effectively what determines the amplitude. So we can say that the amplitude of any sinusoid is going to be equal to the absolute value of a. And again, we use the absolute value because the amplitude will always be positive. Even if a is a negative number, the amplitude will always be a positive number. And we'll kind of bounce back and forth to this definition as we go on with the lesson, because we want to refer back. We want to see and determine what these letters here, how these letters affect the different parts of the graph. All right, so that's the amplitude. I'm going to end this video here, and then we are going to move on to the next discussion, which talks about the period or some of the horizontal motion. As always, ask for help when you have questions. Thank you for watching, and have a wonderful day.